Okay na to. And 12. Okay, good morning, dear students. Sorry for the delay. Now we shall start with antiderivatives. Okay, but prior to discussing the different theorems on integration or antiderivative differentiation, I have prepared here an activity in which you will match, okay, two columns, column A with column B. Column A are the functions f of x equal to 3, f of x equal to m, 10, okay, 10 functions. And along column B, we have in capital, f of x is 3x minus 1, okay, f of x equal to mx, and then c, f of x, 3x to the fourth minus x cubed plus 2x, although it's already matched. But I did not notice that. But I just want you to look into columns A and B. What do you think is the relationship between, okay, the two columns? The functions along column A and the functions along column B. Oh, I failed to jumble column B. I should have jumbled the options in column B. So although it's already batched, any observation regarding column A and column B, it's already in the instruction. So the activity says you are to match the function in column B with the corresponding derivative in column A. So however, I failed to jumble, okay, or to disarrange column B. Okay, so obviously, column B are the original functions and column A are the derivatives of the functions in column B. So for instance, okay, f of x, 3x minus 1 has the derivative 3. Yes? Then letter B, mx has the derivative m. Letter C, f of x, applying power rule, the derivative of the first term. So if we differentiate term per term, this will give a derivative of 12x cubed, correct? And then the second term gives a derivative of 3x squared. And the last term, 2x, gives a derivative of 2. So, C and 3 are, or should I say, number 3 in column A is the derivative of C in column B. In like manner, letter D, 2x has the derivative, baligtad. Okay, this is supposed to be x squared. Okay, let me check. This is supposed to be x squared and this is 2x. Baligtad siya. Okay? So, x squared has the derivative 2x and then cosine x. What should this be? Okay? Letter EN, number 5. Let me put an arrow. Okay, joining the two. Yan. Any comment on number 5? Any comment on number 5? Anyone? Any comment on number 5? Well, let's get back to number 5 in a while. Let's look at number Correct. So Jeric said it has to be negative sine x. Okay, so I overlooked that also. This is supposed to be negative sine x because derivative of cosine x is negative sine x. And then number 6, derivative of the square root of x. You know that square root of x could be written as x raised to 1/2. So by power rule, it's 1/2 x raised to 1/2 minus 1, which is negative 1/2. So that could be written in the denominator to make its exponent positive. So making it 1 over 2 square root of x, correct? Derivative of tangent x is secant squared x, correct? Derivative of e raised to x plus 4. Derivative of the first term is e to the x. And derivative of a constant 4 is 0. Letter I, f of x is 3 raised to x. This is of the form a to the x. And derivative of a to the x, what did we say before? A to the x times the natural logarithm of the base a, which is 3 in this case. So 3 to the x, ln of 3. And finally, letter J, derivative of the logarithmic function, ln of 2x minus 1. Remember the formula, du over u. Okay? Or 1 over u times du. Okay, derivative of 2x is 2 over this quantity. Correct. So 2 over 2x minus 1. So what can you say about columns A and B? Column A, okay, the entries, or should I say the functions in column A are in fact the derivatives of, okay, of the functions in column B. Or we can also say that entries in column B are the antiderivatives of the functions in column A. Okay, so but by anti-differentiation, what do we mean by that term then? By that process or the term antiderivative. So we said a while ago that the functions in column B are the antiderivatives. Okay, the original function, the antiderivatives of the functions in column A. And the process, so it's the opposite this time. So we're given the derivative, we are to look for the original function or that function, that general function given this derivative. So going back, this is the derivative and this is the antiderivative. Okay, so for column A, derivative versus antiderivative. In like manner, for letter B, this is the derivative and the antiderivative is mx. Okay? Number 3, again, this is the derivative and this is the antiderivative. So it's the inverse process. Okay? Theorem. If f is an antiderivative of f on an open interval or an interval I, then every antiderivative of f is given by fx plus c, where c is an arbitrary constant. What do we mean by this? Now, going back to letter, or number 1, I should say, number 1. Is this the only function whose derivative is 3? Is it only 3x minus 1? Anything else? Will this function give the same derivative also? Let me write a function that would give a derivative of 3 also. How about 3x plus 2? Okay, if we differentiate the function f of x equals 3x plus 2, then it gives us the derivative 3 because this constant, when differentiated, gives a derivative of 0. So regardless, or should I say whatever the value of the constant is, be it negative 1, 2, it will end up to the derivative f of x is equal to 3. Therefore, in general, we say that the antiderivative of a function f, small letter f, is f of x, capital F of x, plus c, where c here is an arbitrary constant. Because the functions, okay, f of x, let me use capital letter to be consistent with column B. F of x equal to 3x plus 2, 3x minus 1, 3x minus 10, 3x minus 5, 3x plus 100 will all yield the same derivative. And that is f prime of x is equal to 3. So that's the essence or the importance of the arbitrary constant c. So whenever you integrate rather, okay, integrate or looking for a general function whose derivative is given, we always indicate or include the arbitrary constant c. Now let's look into, okay, formal definitions. Let f, okay, be an antiderivative of f, small, okay, f, the capital letter F, okay, denotes the antiderivative, and the small letter f for, okay, the derivative. For each constant c, the function f of x plus c is the antiderivative of f over the interval I. Now, if g is an antiderivative of f over I, there is a constant c for which g of x is equal to f of x plus c. Okay, just do not forget to include the arbitrary constant c. Okay, for example, for each of the following functions, find all the antiderivatives. Okay, letter A. F of x is equal to 3x squared. Can you identify that function whose derivative is 3x squared? Okay, I'm using a capital F meantime, okay? Later, we will use the proper notation and the proper symbol. Small f for derivative and capital F meantime for the antiderivative. Can you identify that function whose whose derivative is 3x squared? Anyone? Jeric said x cubed. Sige, x cubed. Anything else? Says here all. Okay? X cubed. Pwede ba ang x cubed minus 5? Pwede ba? Yes, because if you apply power rule, 3x squared and derivative of the constant negative 5 is 0. Anything else? F of x, pwede bang x cubed plus 100? Okay, so in general, f of x is equal to x cubed plus c. Okay, the arbitrary constant c. How about letter B? Okay, how about letter B? Can you identify the function whose derivative is 12x squared plus 2x plus 3? Anyone? F of x equal to 12x cubed plus 2x, okay? X cubed plus 3, okay? Kathleen and Jade, Jomar and Jeric, okay, answered correctly. How about letter B? Can you identify the function whose derivative is this? Again, may we use capital letter F muna to mean antiderivative? For 12x squared kaya? Anyone? For 12x squared? It will be 4x cubed, tama? Plus, how about this? X squared, correct? Plus 3x. Arlene's answer is 4x cubed plus x squared plus 3x plus c. Okay, and Jade and also Jomar. You can check, you can verify by taking the derivative. So if you get f prime of x, capital, okay, let me erase muna. Or may we use small letter or sige, f prime na lang to mean it's the derivative. F prime of x, then that gives 12x squared plus 2x plus 3, correct? And C, any constant. So, affix any constant, its derivative anyway is 0, so it does not matter. Okay, so we got this. 12x squared plus 2x plus 3. Now, question, how did you arrive at? Let's go back to letter A first so that we can see the relationship between derivative and antiderivative. Okay, so for letter A, how did you come up with x cubed? X cubed. Remember your power rule? Okay, so let's recall our power rule for derivatives. Okay, let's recall the power rule for derivatives. What did we say? The derivative with respect to x of x raised to n, okay, is equal to, derivative muna tayo. So from here, we can look into the relationship between derivative and antiderivative. Remember that they are inverse processes of each other. Okay, how did we differentiate? Exponent n, x raised to exponent minus 1, correct? Exponent n, x raised to n minus 1. The question is, add 1 to the exponent, make the new power as the denominator of the function. Okay, Jerick said, add 1 to the exponent over exponent plus 1. So, it's the inverse then. So, here, we subtracted 1 from the exponent. We multiplied the exponent, or we took the exponent as a factor, and then subtracted 1 from the exponent. So, we reverse that. So, instead of adding, this time, we have to subtract. So, to bring it back to x raised to n, what must I do to bring this to, okay, the original function x raised to n? So, to undo subtracting 1 from the exponent, we have to add 1 to the exponent and divide it by, okay, that same value, exponent plus 1. So, we now have then the first rule. But prior to the first rule, once more, let's apply that here, your observation. Okay, yung observation muna ninyo. Okay, like what Jerick said, add 1 to the exponent, correct? Okay, to. Exponent, this is the given. Exponent, which is 2, okay, wait, plus 1 over, this has the, okay, factor 3, diba? 3. So, I'm just going to copy 3, okay, 3, this is the original given, over 2 plus 1, exponent plus 1. So, take note that 3 with 3 will cancel out, giving us x to the third power. Okay? So, very good. That's, in fact, the power rule for anti-differentiation. But before we proceed to the theorems or the rules, let's look into the definition and formal notation first of your indefinite integral or the antiderivative. Given the function f, the indefinite integral, okay, of f denoted as the integral of, okay, looks like a letter S. That came from the idea of summation. Because when we get to areas bounded by lines or curves, we will explain bakit kaya ganito ang notation. Letter S, summation. It has to do with the summation notation. F of x dx. The integral of f of x dx. So, this is the most general antiderivative of f. If f is an antiderivative of f, then this is how we denote it. The integral of f of x dx is equal to f of x plus the arbitrary constancy. Most general, okay? Antiderivative. The expression inside, okay, is called the integrand. And variable x is the variable of integration. Okay, so we now read this as the integral of f of x dx is equal to capital letter f of x plus c. Okay? And the process of finding the antiderivative is called integrating. So, antidifferentiation is the same as integration. So, for a function f and antiderivative, okay. So, may we skip that now and then go back to this? Or should I say proceed to the next? Integral of 2x dx. So, which one is the integrand here? The integrand is 2x dx. Ito, 2x. And the antiderivative or the integral is x squared plus c. Again, if you apply your observation from the previous, so for 2x, add 1 to the exponent divided by, okay, exponent plus 1. And then, that will cancel out. This will cancel out 2 here, giving x raised to 2 plus, do not forget to include the arbitrary constant c. Okay? That's the, okay, the antiderivative or the integral of the given. When we say evaluate the following, we mean integrate or find the antiderivative. Next, the collection of all functions of the form x squared plus c, where c is any real number, is known as the family of antiderivatives of 2x. Okay, how does it look like if you try to draw it? X squared is a second degree function. And you know very well that second degree functions are parabolic. Okay, parabola. X squared is a parabola whose vertex is at or along the vertex is at the point 0, 0. But if it's x squared plus c, that depends upon the value of c. So looking into the family of antiderivatives of the given, the graph would simply look like this. It could be y equal to x squared. Ito. The vertex is at 0, 0. Y equal to x squared plus 1, so it's shifted 1 unit up. And then y equal to x squared minus 1, just shift the graph 1 unit down. Okay, so along the y-axis. X squared minus 2, ito. Okay, x squared plus 2, yan. Okay, so this figure shows the graph of the family of antiderivatives for the function 2x dx. So its antiderivative takes the form x squared plus c. Okay, c is any real number. Now we proceed to the theorems because we don't have enough time. What time is it now? Okay, the first theorem is on integration or integral of a constant. The integral of a constant k, denoted by k, integral of k dx is equal to simply kx plus c. Okay, where c is an arbitrary constant. Now you might ask, how did it happen? Remember our theorems on differentiation also. Derivative of mx is equal to m. So the reverse, the integral of m dx therefore is mx. Now we can show the proof. Yan, k. So from your observation a while ago, if you have k, I could write this as x raised to 0, isn't it? Because x raised to 0 anyway is 1. Okay? So, applying your observation a while ago, add 1 to the exponent over exponent plus 1. What will this give us? K and x, correct? Okay, so kx plus c. So, for any constant, its antiderivative or integral rather is kx plus the arbitrary constant c. Okay, so example number 1. Okay, evaluate the integral of 3 dx. 3 is a constant, therefore 3x plus c. We proceed to the next. Okay, unless there are questions. Next, we proceed to integration of a power or integral of a power. Okay, the integral of x raised to n dx is equal to, like what you have said earlier, add 1 to the exponent divided by x raised to n plus 1 divided by exponent plus 1. Okay? Or 1 over exponent plus 1 times x raised to exponent plus 1 plus the arbitrary constant c. Okay, however, you have to take note of this condition. N should not be equal to negative 1. Why? What happens when n is negative 1? Okay? What happens when n is negative 1? Bakit may restriction as to n value, n equal to negative 1? Bakit hindi pwede? Okay? What happens? Obviously, if this is negative 1 plus 1 will be 0, di ba? Negative 1 plus 1, 0, 1 over 0 is undefined. So, hindi pwede. Okay, hindi pwede. Because there is a rule which, okay, a rule which we can make use of when n is equal to negative 1. Okay, Kriza said undefined. Okay, but when n is negative 1, what rule shall we make use of? That we will look into later. Okay, recall your laws of derivatives of logarithms, I should say. It's particularly ln, natural logarithm of u. Okay, so x raised to exponent plus 1 over exponent plus 1. So, example number 2, mabilisan na tayo Okay, evaluate the integral of x cubed dx. So, once more, 1 over n plus 1 times x raised to n plus 1 plus the arbitrary constant c. So, it's 1/4 x to the 4th. Now, if you are not very sure of your answer, then you can take its derivative. So, to check, 1/4 x to the 4th plus c, okay? If you differentiate this, then 4 times 1/4 x raised to 4 minus 1 plus derivative of a constant which is 0. Take note that this will cancel out, giving x to the 3rd. Okay? Okay, and that's the integrand, x to the 3rd. Okay, so you can verify by taking the derivative. We move on to example number 3. How about 1 over x to the 5th power? 1 over x to the 5th power. Take note that by your laws of exponents, we can write this into x raised to negative 5 dx. Okay? Can we still make use of the power rule? Yes. Okay, so applying power rule, 1 over exponent, which is negative 5, plus 1 times x raised to negative 5 plus 1 plus the arbitrary constant c. And when simplified further, this will be 1 over negative 4. There we have 1 over negative 4. And x raised to negative 4, make the exponent positive by moving it into the denominator. So finally, it's negative 1 over 4x to the 4th plus c. Other questions at this point? If there are no questions, then we proceed to example number 4. Integral of the square root of x dx. Okay? Again, from your laws of exponents, we could write square root of x as x raised to 1/2 dx. Okay? X raised to 1/2 ito. Okay? Exponent yan, hindi factor. So, from your power rule, for integration, it's 1 over 1/2 plus 1, x raised to 1/2 plus 1 plus c. But when this is simplified, 1 over 3/2, diba? 3/2 ito. Okay, and this is division, so we can take the reciprocal. It becomes 2/3, x raised to 3 over 2 plus c. Or, this one, x raised to 3/2 is equal to x raised to 2 over 2 and x raised to 1/2, isn't it? Okay, and this is equal to x, and x raised to 1/2 is simply square root of x. Here we have this. Okay, that's how we obtain the final answer. 2x square root of x all over 3 plus the constant c. Next, we proceed to number 3. So, we're done with the first, okay, integral of a constant, and then power rule. Now, constant multiple rule for integration. Now, let k be a constant. and let f be a function that is continuous on an open interval, then we have k, integral of k, constant, times f of x dx is equal to, we could bring out the constant k times the integral of f of x dx. Example, we have evaluate the integral of 3x to the 5th dx. We could bring this out. Okay, bring out the constant 3, integral of x to the 5th dx. So, 3 times, again, applying power rule. Use power rule for this part. 1 over 5 plus 1, x raised to 5 plus 1 plus c. Which when simplified gives 3 times, this is 1 over 6, kaya 3 over 6. X raised to 6 plus c. And then simplify further. Okay, 3 over 6 is 1/2. Okay, so x over 6 or x raised to 6 over 2 plus c. Okay, so as simple as that. Next, how about if we have a sum or a difference as our integrand? All you have to do is to simply integrate term per term. That's the meaning of sum rule for integration. You just simply integrate term per term. So may we go right away to the example. So for instance, find the antiderivative or evaluate the integral of the quantity 1 plus x cubed dx. Then you can simply rewrite this as the integral of 1, which is a constant, plus, because the operation between them is plus the integral of x cubed dx. So, term per term, use constant rule for number 1. So, 1x or x. And then the power rule for number 2, x raised to 3 plus 1 over 3 plus 1, or x to the 4th over 4. Do not forget to include the arbitrary constant c. Okay? Next, example number 7. Okay, example number 7, integrate x minus 11 plus 3 over the square root of x dx. Again, by the integration of a sum, we integrate term per term. Okay, separate this into integral of x dx minus 11, integral of 11 dx plus 3. Okay, so I have expressed over square root of x already as x raised to negative 1/2. So please do not forget that also. Whenever you encounter radicals, express them into exponential form. This appears in the denominator and therefore its exponent must be negative 1/2. Okay, so let's integrate term per term. This is x raised to 1. Okay, x raised to 1. So, plus 1 over 1 plus 1, that would be correct. X squared minus, or x squared over 2. Minus, derivative of a constant is 11x. And then this, apply the constant multiple rule. We have the constant 3, you can bring it out. Okay, and then integrate this as a power. Or you can do it right away as 3x raised to negative 1/2 plus 1/2, or plus 1, I'm sorry, over negative 1/2 plus 1. Which when simplified will be 3x raised to 1/2 over 1/2. Correct? Ito siya. 3x raised to 1/2 over 1/2 plus c. But however, this is division. Okay, division is the inverse of multiplication, right? So if we can, if we make use of multiplication, just take the reciprocal of 1/2, and that's 2. Multiply it to 3, and that will give 6. 6 square root of x plus the arbitrary constant c. Okay, are there questions at this point? Wala pa naman siguro. Ano? Now, we proceed to the next, number 8. How about if we have, okay, integral of 2x minus 3, okay, a product, 2x minus 3 and x squared plus 1 dx. Okay, take note that you only know how many rules at this point. Constant, power rule, constant multiple, integral of a sum. Okay, nothing more. Wala pa kayong alam sa substitution and other techniques of integration. So how shall we evaluate number 8? Okay, so that we can make use of the rules that we already know, then we expand. Okay? Expand the integrand or multiply. Multiply this first so that we can apply term per term integration. So after multiplying, this will give a product of 2x cubed minus 3x squared plus 2x minus 3 dx. Okay? And then apply term per term integration. Integral of 2x cubed dx minus integral of 3x squared dx plus integral of 2x dx minus integral of 3 dx. And then, constants, bring them out. Okay? Or you may retain, it's alright. Then, apply power rule. Okay? So, x cubed, add 1 over 3 plus 1, correct. Okay? So, 2 times x raised to 4 over 4, why 4? It's 3 plus 1, minus 3 times x raised to 2 plus 1, that's 3, over 2 plus 1 is 2, plus 2x raised to, bakit 2? This is 1, plus 1, so 2, over 1 plus 1, minus derivative, integral of, bakit minus 3x ito? 3, okay, in-evaluate na siya, okay? Integral of a constant, okay, 3x plus the arbitrary constant, c. So, simplifying it further, reduce 2 over 4 into 1 half, correct? 1 half x squared. 3 and 3 would cancel out, giving x cubed. 2 with 2 would cancel out also, giving x squared minus 3x plus c. Okay, next. Now, we move on to the fifth rule or fifth theorem on antidifferentiation, the chain rule or integration by substitution. Okay, integration by substitution. Let G be a differentiable function of x and let the range of G be an interval I. Suppose that f is a function defined on I and that f is an antiderivative and u is equal to g of x, then integral of f of g of x times g prime of x dx is equal to the integral of f of u du, which is equal to f of u plus the arbitrary constant c. Now, to better understand this, if we introduce a variable u to represent g of x, look at number 9. There are two ways by which you can integrate number 9. It's either you expand the binomial x plus 1 to the 5th power or we introduce a new variable u. Okay, we substitute. So, this in fact came from the generalized power rule. If you remember, u to the n, okay? So, in like manner, we could make use of the variable u also. So, we introduce a new variable u. Let this be u. Okay, so u is x plus 1. Therefore, we could express this as u raised to the 5. Okay, u raised to the 5 and du, let's find out. So, if u is x plus 1, then du, we let the quantity inside be u, let u be equal to x plus 1. So, differentiate with respect to x, derivative of x is 1 dx. Okay, derivative of 1 is 0. So, you don't have to write or you don't have to indicate 1. It's implied. So, du equal to dx, which means that the original function could be written into the form integral of u to the 5th power du. Okay? And this takes the form u to the n. So, from your power rule, from the second rule a while ago, what did we say? Add 1 to the power over power plus 1 plus the arbitrary constant c. So when we differentiate or when we integrate, when we integrate u to the 5th du, then we simply add, okay, 1 to the exponent over exponent plus 1 plus the arbitrary constant c. There you have it. Ayan, oh. Okay? U to the 6, okay? U to the 6 over 6 plus c. However, we have to bring this back into the original, okay, original variable, which is x. Okay, take note that we let u a while ago be equal to x plus 1. So, you have to express your final answer in terms of x. So, now you return or, okay, replace u with x plus 1. So, we have x plus 1 to the 6th power over 6 plus the arbitrary constant c. Now, you can verify. So, your answer, our answer a while ago is x plus 1 to the 6th power over 6. We try to differentiate. Okay, differentiate. Differentiate means find the derivative. Integrate means find the antiderivative. So, if we differentiate this, exponent times x plus 1 raised to exponent minus 1. Diba? Okay, so, ay may over 6 siya. Sorry, I did not write that. Okay, exponent 6 times, okay, the quantity x plus 1 raised to exponent minus 1. Then this will cancel out, giving the original integrand, which is x plus 1 to the 5th power. Let's go back. Is it the given? Okay. Okay, so this is the given, x plus 1 to the 5th power. Okay, let's look into some examples. Okay, evaluate the square root of 4x plus 3 dx. Take note that we cannot make use anymore of term per term integration here. Okay, we cannot also make use of, okay, we cannot also make use of the sum multiple or sum of a, okay, or integration of a sum. Therefore, we have to make use of substitution. So, we let the quantity inside the radical sign or the radicand be our u. Take note that we could write this as, this could be written as 4x plus 3 raised to 1/2. Okay? 4x plus 3 raised to 1/2. So, we let the quantity inside our parenthesis be u. So, let u be equal to 4x plus 3. Now, differentiate u with respect to x. Derivative of 4x is 4 dx. And the derivative of 3, which is a constant, is 0. So, our goal is to express the given in terms of u and du. Okay? So, we know that this is equal to, in terms of u, I could now write this as u raised to 1/2. Okay? In terms of u, this now could be expressed as u raised to 1/2. But how about dx? From here, we found out that du is equal to 4 dx, but I want dx alone. Dx lang. Okay, so to get dx, we simply divide both sides by 1/4, or by 4 rather. So 1/4 du is equal to dx. So that means I could change my dx. I could express dx in terms of this now, 1/4 du. So times 1/4 du. Okay, I hope you could follow. And from the constant multiple rule, we could bring this out. Okay, though, we can bring out the constant 1/4. There you have it, there. Okay, 1/4 integral of u raised to 1/2 dx. Okay, so now we are ready to apply the power rule. So 1/4, there, the constant 1/4, we just have to copy it, times, applying your generalized power rule, u raised to 1/2 plus 1, exponent plus 1 over 1/2 plus 1. Okay? 1/2 plus 1 is 3/2, 1/2 plus 1 is 3/2 plus the arbitrary constant c. So, when we simplify, this is the same as 2 over 12. Yan. 2 over 12. If I multiply the 2, it's 2 over 12. But when simplified, 2 over 12 is 1/6. Okay? U raised to 3 halves plus C. Okay? Now, bring this back into the original variable. U is, take note that our U is 4x plus 3. So, 1 over 6 times 4x plus 3 raised to the 3 halves plus the arbitrary constant C. Okay, now we proceed to example number 11. Or before we proceed to number 11, any questions here? Let me give you another example under substitution. Evaluate the integral of, can you evaluate the integral of okay. So, for example, evaluate the integral of 2x times the quantity 4x squared plus 1 raised to 7 dx. Okay, let this be letter A. Can you try? So, like what we did in the previous, we introduce U. We let U be 4x squared plus 1. Okay? So, what is du? What is du? Okay, differentiate u with respect to x. It's 8x. Okay? And derivative of 1 is 0. So, 8x dx. Okay? So, looking back, going back to our original function, we have, I could rewrite this as the quantity 4x squared plus 1 raised to 7 times 2x dx. Okay? So, in terms of u, this one will now be u raised to 7. Take note that this is our u. So, u raised to 7, and how about this? Okay, we find an expression for 2x dx from our du. We need 2x dx. So, this is 8x dx. So, to come up with 2x dx, we divide both sides by 4. Yes? So, that means get 1/4 of both sides. Divide both sides by 4. Then, that gives du, or 1/4 du rather, is equal to 2x dx. Okay, bakit 2x dx? Ito kasi gusto nating palitan. In terms of du. Okay, in terms of du. So, instead of 2x dx, this will now be replaced or substituted by 1/4 du. So, I'm going to write here now 1/4 times 1/4 du. And what happens with 1/4? The constant 1/4, from the constant multiple rule, we could bring it out. So, 1/4 integral of u raised to 7 du. And now, applying power rule, it will now be 1/4, okay, times u raised to exponent plus 1, that's 7 plus 1 over 7 plus 1 plus the arbitrary constant c. Okay, when simplified, what will this be? U raised to 8 over, this is 8 times 4, 32, correct? Okay, 32 plus c. Are there questions at this point? Now, bring this back into the original, okay, variable. U is 4x squared plus 1 raised to 8 all over 32, okay, plus c. Okay, plus c. 4x squared plus 8 raised to the 8 power over 32 plus c. Now, if you want to verify, then you can differentiate. Okay? Okay, so you can differentiate. Sige, ipakita natin to check whether our answer is correct. Okay, 4x squared. 4x squared plus 1. Wait. Okay, 4x squared plus 1 raised to 8 over 32 plus c. So let this be our f of x. If we get its derivative, okay, f prime of x will be, what will this be? Okay, exponent 8 times 4x squared plus 1 raised to exponent minus 1. This is over 32 times, okay, the derivative of the quantity inside the parenthesis is 8x. If simplified, what will this be? 8 times 8 is 64. 64 divided by 32 is 2x times 4x squared plus 1 raised to 7. Now, let's verify. Is this the given? Is this the given? So, let's see. 2x, 4x squared plus 1 raised to 7. Okay. 2x, 4x squared plus 1 raised to 7. So, that's it. Okay? So, you can always verify your answer by differentiating, okay, or by taking its derivative. Other questions at this point before we proceed to the next? Let me check the time. Oh, it's 11:03. May klase kayo sunod. Anong time? Anong time ang klase nyo sunod? Dalawa na lang naman ito. Bakit bumalik tayo sa number 9? Okay, now we proceed to antiderivative of exponential and logarithmic functions. Okay, recall that the derivative of e to the x is e to the x dx, and derivative of a to the x is a to the x ln of a. Okay, so the integral, therefore, of e to the x dx is simply e to the x plus c, and the integral of a to the x dx is equal to a to the x over ln of a plus c. Okay? Now, example number, this is supposed to be example number 11, not example number 9. Integrate 3 e raised to x dx. So, from the constant multiple rule, we can bring out the constant 3. Okay, 3. And then integrate e to the x dx. Integral of e to the x dx is e to the x itself plus the arbitrary constant c. So, 3 times e to the x plus c. Next, number 12. How about 1 over e to the x dx? From your laws of exponents, you know that this is the same as the integral of e raised to negative x dx. Okay? So, here, our exponent is no longer x but negative x. So, we can make use of substitution here. We let our exponent be u, negative x, and derivative of negative x is negative dx. So, express this in terms of u also, just like what we did in the previous. So, I could rewrite this as, okay, integral of e to the u and dx. What have we found from here? Dx is negative du. Okay? So, from here, dx is negative du. So, it's not just du but negative du. So, in fact, we can write this as integral of e to the u times negative du. Okay? Or negative 1. So, that negative 1 could be written outside the integral sign. So, we could write this as there. Okay? We have negative integral of e to the u du. So, apply the formula. It's simply negative e to the u plus c. So, negative e raised to negative x plus c. Okay? So, whenever the exponent is not x, okay? For example, or another example, number 11, the integral of 2x cubed times x raised to the 4th power dx. So, it's no longer e to the x but e to the x raised to 4. So, in here, again, we let u be equal to the exponent of e, which is x to the 4th power. And du is equal to 4x to the 3rd power dx. Okay? So, I could rewrite this in fact as, tapusin lang natin ito, as e raised to x to the 4th power times 2x cubed dx. And express it in terms of u. So, this will be, ito, magiging integral of e to the u. Ngayon, hanapan natin ito ng kapalit niya in terms of du. Ganun lang naman. Okay? Hanapan natin ng kapalit yung 2x cubed dx. Saan? Dito. 2x cubed yan. 4x cubed ito. So, what should we do? We now divide both sides by 2. So, this is the same as 1/2 du is equal to 2x cubed dx. So, anong gagawin kay 2x cubed dx? We will replace it with 1/2 du. So, times 1/2 du. Pero ang formula natin is e to the u du. So, pwedeng ilabas si constant. So, we can bring this out. Kaya, magiging ito. Okay? Ito na siya. 1/2 e to the u du. So, ito, e to the u, and ito, 1/2 du. Nung ginawa natin kay 1/2, bring this out. So, there you have 1/2 integral of e to the u du, and integral of e to the u du is e to the u. Okay, so 1/2 e to the u plus the arbitrary constant c. But what is our u? It's x to the 4th. So, finally, 1/2 e raised to x to the 4th plus c. Next, for trigo, itong dalawa lang muna. The rest will be for next meeting na lang. You know that the integral or the derivative of cosine x is negative sine x, which means therefore that the integral of sine x must be negative cosine x plus c. And that derivative of sine x is cosine x, therefore the integral of cosine x is sine x plus c. Marami pa ba? Ito na lang. Hanggang the two trigonometric functions lang tayo. But before this, ito muna. I prefer working on example number 12 muna before number 11 because this is simpler. Okay, integrate the quantity x squared plus sine x dx. Okay, this is a sum. So we can use integral of a sum. So term per term integration would give us integral of x squared dx. Use power rule. And then here use the trigo rule. Okay, rule for differentiating trigonometric function, particularly sine x. So from your power rule, this is x raised to 2 plus 1 over 2 plus 1, correct? X cubed over 3 minus integral of sine x dx is negative cosine x plus again the arbitrary constant c. Okay. Now, paano kapag hindi na siya sine x, hindi cosine x, kundi cosine 5x dx? Gaya nung kanina, we let this be our u. Okay, because we know anyway that integral of, from our rule, go back, integral of cosine x dx is is sine x plus c. Okay, so we let 5x here be our u, and du, differentiate u with respect to x, it's 5 dx. Okay, so your cosine 5x dx in terms of u becomes cosine u, kasi nga u si 5x, ito si dx, hanapan natin ng kapalit in terms of du from where? Dito. X lang kasi ang nandito, hindi 5x. Okay? Or hindi 5 dx. So, to get rid of 5, we divide both sides, okay, by 5. Or that's the same as 1/5 du is equal to dx. So, si dx will be replaced by ito. Okay, 1/5 du. And what can we do with the constant 1 over 5? We could bring this out. Okay, so write it outside the integral sign. Now, we have 1/5 cosine u du. Now, you apply the rule. Okay, integral of cosine u du is sine u plus c. So, 1/5, yan, 1/5 of sine u plus c. But bring this back into the original variable, u is 5x. So, final answer, 1/5 sine 5x plus c. Number 13. How about if we have integral of 1 over cosine squared 3x dx? Now, this is applying some of the identities. You know that 1 over cosine squared is 1 over cosine squared 1 over cosine x times 1 over cosine x is secant squared x. Yes? Okay? And which trigonometric function has the derivative? Okay, secant squared x. Okay, it's the tangent. Okay, tangent. So, integral of secant squared x dx is equal to tan x plus c. Or a more general form, if we have secant squared u du, then it's equal to tan u plus c. Okay, so express the given now in terms of secant squared. So now this takes the form secant squared u. Okay, so we let u be 3x. Okay, and then differentiating u with respect to x, du is equal to 3 dx. Ulit, 3 dx. dx lang ito. Okay, so get rid of 3 by dividing both sides by 3. Or getting 1/3 of du is equal to dx. Okay, so what will I replace dx with? I'm going to change or replace dx with this 1/3 du. Okay, ayun na siya. So, secant squared u, 1/3 du. And what will I do with 1/3? Bring it out. Okay, 1/3 secant squared u du. And what did we say? Derivative of secant squared u du is tangent u plus c. Okay, so 1/3 tan u plus c. But what is u? It's 3x. Okay, u is equal to 3x. So bring it back to the original function, 3x. 1/3 tan 3x plus c. Okay, so we end up with that assignment na pala. I will post it in lens na lang. Because it's already 11:14. Are there questions at this point? There are questions. If there are questions, please send me message via lens or via FB Messenger. Because it's already 11:14. Sorry for taking 14 minutes of your vacant time sana. Okay, if there are questions, once again, please send me message via FB or through lens. Assignment will be posted in lens. Okay, so that's it for next meeting. We will continue with more techniques of integration. Please read something about trigonometric substitution, integration by parts, integration by partial fractions. Okay? Okay, thank you very much. Bye everyone.